Okay, we all know the story of the Titanic, right? The glamour, the tragedy, the whole legend. But tonight, we're not just retelling that story. We're opening a cold case. We're going to investigate the science of why it really sank. The clues? Well, they've been sitting at the bottom of the ocean for over 100 years. So, let's get into it.
So, here's the big question, the one that's bugged people for a century. The Titanic was called unsinkable, so why is it at the bottom of the ocean? It's a total paradox, right? To get to the bottom of it, we're going to have to put on our detective hats and look at the evidence through the lens of physics, material science, and, some good old-fashioned forensics.
But before we can really dig into why it failed, you've got to appreciate what an incredible piece of engineering this thing was. I mean, just look at this picture. At the time, the Titanic was literally the largest movable object ever built by human hands. It was an absolute marvel.
Okay, so let's start our investigation right there, with that unsinkable design. What was the technology that earned the Titanic its legendary and, well, tragically ironic reputation?
Okay, first clue. How in the world does a 66,000-ton steel giant even float in the first place? Well, it all comes down to a really simple principle: buoyancy. That's just the upward push that water exerts on anything you put in it.
And the real genius here is the shape of the hull. It's designed to push aside or displace a huge amount of water. As long as the weight of the water it pushes away is equal to the weight of the ship itself, boom, it floats. It's an idea that's been around forever, all the way back to Archimedes. But buoyancy is one thing. The real key to that unsinkable claim, the technological ace up its sleeve, was this right here, a revolutionary safety system. We're talking 16 watertight compartments, sealed off by these enormous, heavy-duty doors.
And this is where all that confidence came from. The designers ran the numbers, and they figured the Titanic could stay afloat even with its first 4 compartments completely full of water. They thought, no collision in the world could possibly damage more than 2 compartments, so 4, that was just overkill. The design seemed absolutely foolproof.
Okay, so we've seen the ship's defenses. They were pretty impressive, right? Now let's turn our investigation to the other player in this drama, the attacker, the iceberg.
Now, this wasn't just some chunk of ice. No way. This thing was ancient. Its story starts 3,000 years ago as snow falling on Greenland. Over centuries, that snow got squeezed into super dense glacial ice. And for all that time, it was slowly making its way to the sea until it broke off and drifted right into the Atlantic shipping lanes, at that exact spot, at that exact time. Talk about a date with destiny.
And here's the really scary part. You know that saying, just the tip of the iceberg? Well, this is it, literally. What the lookouts could see above the water was only about 13% of it. The other 87%, the vast, destructive part, was hidden completely out of sight, right below the surface.
Now this is where it gets really interesting. You might think it was just bad luck, but check this out. The environmental data shows that the Titanic was sailing into an unusually dangerous situation. In April of 1912, there were way more icebergs drifting that far south than usual. We're talking 4 times the average. It wasn't just a shipping lane, it was basically a minefield.
So, the ship hits the ice. But what really happened to the hull? This is where we get to debunk a huge myth. For more than 80 years, the real answer was a complete mystery, buried under 2.5 miles of water.
For decades, this was the story everyone believed, that the iceberg ripped a giant 300-foot-long gash down the side of the ship, like a can opener. It's a dramatic image, it makes sense, but it's just not what happened.
The truth didn't come out until 1996. A scientific expedition went down to the wreck with some really cool sonar tech. This device, a sub-bottom profiler, basically let them use sound waves to see through all the mud that was covering the hull. And what they found, well, it changed everything.
And the truth was honestly shocking. The total damage was only about 12 square feet. That's it. We're talking about an area roughly the size of a single door. So, how does damage that small sink the biggest ship on the planet?
Well, here's the key. The iceberg didn't just rip a huge hole in the ship. It was more of a glancing blow. It popped open a series of 6 thin slits across 6 different compartments. Remember that unsinkable design? It was only built to handle 4 flooded compartments. The iceberg outsmarted it by, 2 compartments.
And because those openings were deep underwater, about 20 feet down, the water pressure was incredible. It forced water into the ship at a rate of almost 7 tons per second. The bow started to sink, and as it sank, Water just spilled over the tops of those watertight walls into the next compartment, and then the next, and the next. It was exactly like tipping an ice cube tray.
But hang on. That raises another question, right? This ship was supposed to be the strongest ever built. So why did the seams just pop open like that? To answer that, we have to go from the massive scale of the ship down to the microscopic level. We're talking about a hidden flaw in the materials themselves. Okay, see these massive steel plates? They were held together by 3 million rivets. Think of them like the stitches holding a piece of clothing together. If those stitches break, the whole thing falls apart. The strength of those rivets was absolutely crucial.
So when scientists analyzed rivets they brought up from the wreck, they found the smoking gun. A lot of them had way too much slag in them. Slag is just junk, an impurity that's left over when you make iron. A little bit is fine, but too much makes the iron brittle instead of strong. It turns out the shipyard was in a huge rush, and some of the rivets they used were just lower quality.
So here's what likely happened. In the freezing cold water of the Atlantic, those brittle rivets became even more fragile. When the ship hit the iceberg, pop. The heads of the rivets just snapped right off, like glass. The steel plates pulled apart, and that's what created those 6 thin slits that let the water rush in.
So what's the verdict? What really sank the Titanic? Well, as we've seen, there's no single smoking gun. It wasn't just one thing. It was a perfect storm, a tragic, perfect storm of failures all coming together at once.
Let's just run through it. It's a whole cascade of failures. First, you have way more icebergs than usual. Then, the decision to keep going at high speed. Then you get a glancing blow that just happens to damage 6 compartments, not 4. The physics of water pressure does the rest, and it's all made possible by a hidden flaw in the rivets. Literally, every single link in the chain of safety had to break, and it did. So we've solved the science of what happened back in 1912. But the story of the Titanic teaches us this timeless lesson, right? That even our most advanced, most unbeatable technology can be brought down by a chain of events nobody saw coming. And it really makes you wonder, what perfect storms are waiting out there for the technological marvels of our time?